5G, and consumer electronic solutions. With over 20 years in Silicon Valley, he brings extensive technology and business experience.
Happy to be here.
Finally, Zili Yang, electrical engineering and high-speed field applications engineer based in San Jose, California, specializes in Hiroses high-speed connectors up to 112 gigabits per second, ensuring top performance for advanced applications.
Thank you for introducing me.
Thanks, Dave, for joining us. More and more customers are trying to put more data at higher speed. Can you share an experience with you have to help customers solve these challenges?
Yeah, absolutely. So we work with a lot of customers, and one in particular I was thinking about was a customer in the consumer electronics industry. They build small office, home office type router and wireless equipment, and they had some challenges. We look at those devices. They have a small industrial design. They have tight spaces, lots of heat to deal with inside that tight space, a lot of connectivity issues there. And in this particular case, they were trying to connect a couple of boards together on the inside of their box. And the tight space meant that they had to get power, they had to get data between these two boards. They were using two different connection options before, and now they needed to combine that down or make that easier for them to do and reduce the amount of resistance to airflow inside the box. So really tight space. So in the application we worked with them, we were looking at our FX23 series, which is a floating board-to-board connector, and it offers the height range they needed was between 20 and 25 millimeters, so that was perfect for their application. The hybrid power and data in that situation, so we were delivering 3 amps per contact power, 4 contacts on the inside of that design. That was a big benefit for them, and it supported the data speeds they were needing, which was PCIe 3.0, looking at 8 gigabit speeds.
So you mentioned floating connector.
Mm-hmm.
Why was this feature important for this application?
So floating, most folks initially think of floating, I'd say most, right? It's relatively new technology, but floating connectors offer absorption of alignment between a couple of connectors. So if you have more than one board-to-board connector, floating will absorb the tolerance between those two different connectors inside that board. Now in this particular case, the customer was actually only using one board-to-board connector. And floating wouldn't necessarily benefit them in that situation, but for them, we're talking about a product that's built in high volume and tight spaces. The boards are mounted on the shell. There's not a lot of control of positioning as much, so that floating allowed some misalignment. And if they didn't have that, if there was a misalignment as they tried to press the boards together, they could potentially damage the connector or damage the board. And that allows them to absorb it, makes the manufacturing process easier.
Yeah, I see that floating feature helps in 3 aspects. 1, during the design to help with tolerance stack up. 2, during the assembly for misalignment. And 3, during the operation to make it more reliable contacts, especially, for example, for vibration. You also talk about PCIe 3.0, around 8 gigabits. What speeds were the customers using before?
So before they were sub gigabit speeds. So they were running PCIe 1.0 type speeds. But with their, you look at all these devices you have in your household these days, everything connects to the internet. So they needed more data bandwidth on the system internally. So they needed 5 gig is what they really needed. But the FX23 series gives them a little bit of headroom. So at 8 gig capability on that connector or higher, that connector offered that headroom that they needed for future growth.
Why was our FX23 great for this application? What made it stand out?
So there was a couple of features in there. Obviously, floating we already talked about a little bit, and we talked about the data speed. But the other thing that I didn't really highlight too much is that hybrid power and data combination. These days there are a lot of connectivity, lots of power demand in these devices. So having those power contacts was really a big advantage. So now that you went from 2 connections down to 1 connector between the boards, that just saves money ultimately because of fewer connectors. Makes the assembly process easier. Easier means less time equals less cost. So that's a big advantage for a customer.
Thanks, Dave. Mark, we hear about challenge for a customer about higher speed, combining signal and power. Did you run into a similar case where you have to help a customer with these challenges?
Oh, absolutely. Maybe a fairly recent good example that I want to share is a customer doing a small small, medium handheld point of sale device that had a whole lot of electronics packed inside a small form factor, including high frequency processors, high resolution display, high resolution touch panel, and multiple high frequency radios in there for communication purposes. So amongst other challenges, two primary challenges they needed help finding solutions for involved a very small form factor with a variety of pin counts, but also something that was going to help them mitigate the EMI concerns that were a result of all of these noisy elements, that I just described inside a small package in close proximity to each other. So we steered them, and they were very happy to find a brand new product of ours introduced within the last 6 months, the BK35, which is a micro miniature connector that has integrated metal shielding built into the plastic structures of both halves of the mating connector itself.
Yeah, tell me more about this integrated shielding and how benefits for both radiating emissions and also to protect for immunity.
I'd say starting a few years ago, during the emergence of 5G in many products, and even a little more recently, the emergence of high frequency domain 5G radios in a lot of products, consumer products in particular for my interest, we've recognized, and some of our lead customers then were recognizing the need for doing the same EMI mitigation. So what we're on today is about our 5th generation of a integrated shield. And by integrated shield, the analogy I like to use that a lot of engineers can relate to is a shield box structure. And you've probably all seen pictures of PCB boards with aluminized metal boxes that are literally soldered around elements of components that have high frequency noise that they want to shield from other parts. So what we've tried to do, I like to say, is to emulate having a shield box actually tooled into, in our case, molded right into the plastic housing of these little tiny connectors. So it's a seamless 360-degree metal shield. There's one on both halves of the connector, so combined you sort of get a nested double shield effect, if you will. And just to highlight the scale that I'm talking about, which was this customer's other big challenge, I'm talking about something that's probably an order of magnitude smaller than the FX23 that Dave was just talking about. We're talking about connectors whose total stack height, when they're mated, can be as small as a 0.5 millimeter in total height. So 3 mated pairs could stack up within the thickness of a penny, just to put it in perspective. So that's what I mean by integrated shield. So we've got an integrated shield in the BK35 that addresses this issue. In addition, it addresses, the BK35 addresses another issue that is also some analogous to what Dave was talking about, and that is this customer needed the ability to route power over the same path. They didn't have room to put additional connectors into their form factor. So what we've been doing also, and it's included in this product I just talked about, is adding some really beefy power rails, relatively speaking, beefy power rails at the ends of both of the connector. In this case, the BK35 has 4 of them. They each handle 2.5 amps, so together you could have a 5 amp forward and a 5 amp return, which is a lot of power for a small handheld device, and gave this customer plenty of margin to route power as well as their high frequency signaling.
It's impressive how we can put all these features in such a miniature, very small component. So what speeds was the customer using?
One of the protocols that was pushing the frequency was MIPI, which is a very popular protocol, signaling protocol that engineers choose to route to both sensors, imaging sensors, and to cameras. In this case, they were using it to route to their high resolution display. So MIPI would be one of those high frequency examples in this case that was being used.
What other challenges did the customer have to face in this product?
Right. Well, I want to throw in a comment about 2 additional factors that affect both this customer, but a lot of similar customers that are doing the same types of products. And one would be the fact that, well, we like to tout, and we're really on the bleeding edge of micro miniaturization, as I just pointed out. And for a lot of customers, the smaller the better, period. So they want us to go even smaller. But many customers, and together, we as a supplier are recognizing today that it's not always all about having the very smallest form factor, but also having some variation in some of those dimensions. And one of the key variations that we are recognizing is important is the Z height. You might imagine one example would be that you have multiple cables being routed inside the product, sensors and cameras and touch screens. If you have multiple cables that are all stacked up at the exact same height, well, it's easy to imagine they're going to interfere with each other when you try to actually route those. So having some options on the height of even these smallest connectors gives them another degree of freedom, the engineers in the Z direction, as they're trying to route all of these signal paths together. So that's one. And I just throw in another little sort of piece of education for people who aren't so involved in the connector world like we are. We talk about a lot of our types of connectors as board-to-board connectors, right? But certainly in the small domain in particular, the majority of our customers are going to end up using those as a board to FPC, meaning one half of the connector is surface mount soldered to a rigid PCB, but the other piece of the connector is solder mounted to a FPC, which is a little flexible cable. That's going to go on to the rigid PC board. Now, there are cases where even these small form factor products are doing a hard board-to-board connection, maybe a small daughter board that might have some radio circuitry on it or a display or a sensor. In that case, they're running into the same types of alignment concerns that Dave talked about. So we've actually introduced in the last 12 months a couple new families of these tiny micro miniature products that actually sort of amazingly have these same spring-loaded X and Y shock mitigation or misalignment mitigation structures built into them. So we're really trying to cross over and recognize that some of these same issues that different customers have need to be addressed at many different form factors. So those are a couple examples.
Thanks, Mark. So in the first two cases, we hear some common challenges. Smaller space, signal integrity, combining signal and power. And the ranges of speed here were the 5 to 8 gigabits. But what if the customers have to deal with much higher frequencies? And we're talking about speeds in the 56 gigabits or higher. Zili, can you tell us an example where you help a customer solve this problem?
Certainly. So one of our customers in telecommunications, they needed a very reliable high speed, so 56 gigabits that you mentioned, board-to-board connector. And in telecommunications, the design cycles range from 3 to 5 years compared to a standard maybe like 1 year design cycle for consumer electronics. And over the course of those 3 to 5 years, technologies can change very quickly, new technologies can be introduced, and also sometimes our customers' needs change within those 3 to 5 years. So they need some flexibility in the design. So in this case, we proposed the IT8, which has all these features that can help meet their demands.
So you talk about long design cycles, and as you are saying, in a long design cycle, things change. The packaging, the structure can change, the form factor, new technology, speeds. How does this series help the customers during those changes?
Yeah, so the IT series has the 3-piece design, which means there's 3 pieces to the connector, and this allows a lot of flexibility and able to change your stacking board-to-board height. So in this specific case, our customer, when they first designed this IT8N, they're looking at 25 millimeter stack height. But as the design moved along, they had to change it to 24 millimeter stack height. And so you're able to easily achieve this just by changing some of the part numbers of the plug and the interposer. So they changed the plugs from 0H plugs to 1H plugs, and the interposer from 25H interposers to 22H interposers. And to get the stacking height, you just add all the sum of the numbers, and that's the 24 millimeter stacking height that they're looking for. And so we also realized that changing from stack height, the SI performance, the signal integrity performance is very important. So the IT8 series covers from stack heights of 14 millimeters to 46 millimeters. And typically when you go to taller stack heights, the signal integrity performance gets worse. But the IT8 series, it's so well designed that there's so much margin that even if you're going from the lowest stack height of 14 millimeters to 46 millimeters, you still get a very good signal integrity performance. Additionally, 3-piece design we found has other benefits. So one of the things is that the interposer doesn't go through reflow. So that means that that piece doesn't have to absorb heat that the solder and joints need. So that reduces the amount of issues you might have with soldering. And additionally, with the assembly process, you can just put the interposer onto the M side plug, then the D side plug with the daughter board onto the interposer. You screw in the holes for these spacers, and that's it. That's the assembly process. It's a very straightforward and easy process.
Yeah, staying on this assembly process topic, these connectors have a lot of pin counts. How about the weight? How do they deal with that in manufacturing?
Yeah, so one of the things with the IT series is the high pin counts. So we're talking about 288 pins, and sometimes our customers require even two of these, so 500 plus pin counts. And so because of these high pin counts, they have very thick and heavy PCB boards where they have to put components on both the top side and the back side of the board. So when you're going through second reflow where some components are on the back side, if it's too heavy, with the weight, sometimes the parts might end up falling off and causing even more assembly issues. So because the interposer, you have an extra piece that doesn't go through the reflow, doesn't go through second reflow, there's very little chance of that actually falling, the part falling off and that happening. And we actually seen some of our competitors that that have the traditional two-piece design as opposed to the three-piece design. This actually happened where the component is going through reflow and it falls off during the reflow process, and that causes even worse assembly issues. They have to reflow again. It's just a headache. And the three-piece design helps with that issue.
So the journey for using a new product is not just the design, the connector selection, it's also addressing other issues that come along, like manufacturing. So we offer design guidelines, correct, and manufacturing guidelines to help customers?
Yeah, so the IT series provides design guidelines, which includes things like routing and how to best place the connector, and even example cases of how you might use the connector so that our customers can use that as reference. Because for the signal, it's not just going through the connector, right? It's going through the PCB, it's going through maybe some cabling as well. So you'd consider the entire channel. And the design guideline actually has recommendations for some of the traces and the vias and all that stuff too. On top of that, not just for the designing part, but for our contract manufacturers who was actually putting the things together, we have assembly guidelines. So it details out, the instruction process I just talked about with the screws and how to best mate it, but also very commonly asked questions. So for example, what kind of recommended solder paste you might end up using, what kind of stencil thickness, that sort of thing, to also best help the contract manufacturers not have any issues on that side as well.
Yeah. So this three-piece scheme for connector solution helps a lot with the design and manufacturing. Tell us a little more about other high-speed connectors in our products.
Yeah, so I focused mostly on the IT8 when I was talking about this, but we also have some lower speed connectors that have the same three-piece design. So an IT3, which supports up to 10 gigabits per second, and the IT5, which supports up to 25 gigabits per second. And our next generation of the IT8 series is called the IT16. That can support up to 112 gigabits per second. So very, very cutting edge of speeds. And all these three, IT3, IT5, IT8, IT16, all have this same three-piece design. So, this has the same familiarity as our customers who have been using previous generations, easily change to higher speeds, as well as, has that same benefits as well of all the manufacturing and assembly benefits.
So this customers was using 56 gigabit, yet we're already working on the 112 gigabit solution for future needs, correct?
Yeah, so we found that, customers, they plan and design that with the next generation in mind, right? So as soon as they use 56, they're asking, okay, when is the 112 gigs coming out, and so we work with them, ask them, okay, what are your requirements? What kind of protocol are you looking at 112 gigs PAM4? And so we use that to help design the next generation as well.
Yeah, because we're a forward-looking company, we try to anticipate customer needs. So when they get there, we are there also with our products. So Dave, we hear, although different industries, different products, we hear a lot of common challenges. What commonalities have you found in hearing these three cases?
I was just thinking as you was talking about design guides, and my customer that I was working with, we actually contacted our team members on the high-speed team to help our customer do some of the evaluation of the board layout and design to help them get the speed performance where they needed it to be, especially considering all the challenges in their electrical design. Commonality, Mark's stuff was really cool. The small stuff, and connectors, but the speed's there. I mean, the video systems, the high speed, the RF, we got RF signals in our router devices, wireless devices. All that is common. We're seeing consumer electronics and high-speed backplanes all combined together, and even in industrial markets, there's lots of commonality.
So all these challenges mean there's changes in the market. Can you give an example of how Hirose is adapting to these changes?
Yeah, well, it's funny. It's a constant thing for us because we go out and we visit the customers, and we have to listen to them and understand where their applications are going. We have to see if they're asking for 56 gig today, what are they going to be asking for next? If they need 0.6 millimeter, well, are they going to be looking for 0.5? Do we need to develop that? And where those challenges? We ask the customer that type of stuff when we're working with them, and we see that size getting smaller, the pitch getting tinier. I see that all the time in the applications that we're coming across at desk on a routine basis. Hirose has to look at this and figure out where the market's going, where are they going in the future. Because our customers don't always, Mark, I think you mentioned it, our customers don't always know what the latest technology is in the connectors. Mm-hmm. And this is absolutely an area that we have to teach them so they don't have to waste their time trying to figure it out. We try to figure it out for them in advance, and that's a big plus for us.
Yeah, Mark, in your case, you talk about handheld devices. Mm-hmm. That's not just used for consumer electronics. That could be used in industrial or medical applications. Can you tell us about other products for our consumer electronic groups that serve these other markets?
Yeah, I mentioned some other features in our board-to-board or board-to-FPC type products, such as the variable heights and the active floating capabilities. Just throw in one more mention of those quickly. We also actually have some active locking connectors. Retention force is a big area that comes up with some customers too, who might again be in an environment where their product is going to be under some shock or vibration. And in some of these cases, the smaller connectors, they're low mass. It doesn't take a lot of force for them to come apart. So we actually have some options available that actually have, I call it deadbolt lock. It's literally a sliding lock with multiple metal deadbolt, little micro miniature, but little deadbolt hooks that are really going to keep it together. You're going to tear the surface mount solder off the PC board before the connector is going to come apart. But anyways, that was just one of them mentioned. Another large family of products and connectors that again cross the board for a lot of different applications are a family called ZIF, which is zero insertion force. These are a one-piece connector solution. Instead of two mated pairs, it's a single piece that's soldered onto a PCB board, and the naked end of an FPC cable simply slides or is inserted into those. A typical ZIF connector would always include some sort of lever or latch that's manually activated, meaning it needs to be held open until the cable is manually inserted and then manually closed with the cable inserted in the proper orientation. We've started to build out a whole bunch of variety in our ZIF solutions, including ZIF products that support shielded FPC or FFC cables. In my world, going down to those same tiny dimensions of ZIF connectors that are sub-millimeter, down to 0.6 and 0.5 millimeters in total height. And a large family of products that has been pretty well received and we're growing out very rapidly is one we call our One Action family. One Action is, I think we should call it auto locking, because that's really what it does, is instead of all these little manual motions of actuators I just described, the connector doesn't need to be touched at all. The assembler or the assembly operation just consists of inserting the end of the FPC cable. Bang, you've got some spring-loaded locking tabs that automatically seal that in place. You get some visual cues that are easy to visually, through automated vision or through manual inspection, quickly determine that it's properly seated. And on top of that, you get a nice tactical click sensation only when it's properly inserted. So again, that's our One Action family of products. It's really growing very rapidly to spread across a lot of our ZIF solutions.
Yeah, I understand also the One Action has some advantages in shipping, correct?
It's actually got, I describe it as having a threefold types of significant advantages. First one I start with is a design advantage. Again, going back to that same access, the motion of a typical ZIF connector also requires that the product is designed to maintain the mechanical or physical access point for an assembler to reach in and do that locking mechanism. That actually is sort of presents a keep out area that a designer has to keep in mind. They can't put another board right on top of the connector necessarily. They can't put tall componentry around the near in proximity of the connector because that space has to be kept free for the actual locking mechanism. That all goes away in the one action. So all you do is slide the cable in. You can now have a much tighter design or a relaxation of those constraints around it. So design advantage is one. There's a logistics advantage. Typical or legacy ZIF connectors also most frequently need to be from the factory to the final assembly process shipped and maintained with that actuator lever I talked about held in an open position, because closing those levers without a cable in place, especially for the micro types of solutions, can actually deform those tiny little metal contacts inside and degrade the operation somewhat. So that's a second advantage. And the third and most obvious one maybe is that advantage of assembly time. We've done our own quick studies and easily shown that we've got a multi-fold decrease in the amount of assembly time required for each process versus the insertion, closing of the lock type of actuator.
Yeah, and the advantage in assembly is not only the time, it's also the training. You don't need to train people you have to open the lever to the back, to the front, what that actuator it is. They just have to press it in, easy to do.
Yeah.
So all these connectors are used in many industries. Today we talk about 3 cases that cover 3 industries, but we are not limited to that just those 3. Our challenges are very similar across industry. And our connectors also can be used in medical and automotive. Dave, can you measure some examples of how we fit in the automotive and medical industry?
Sure. Yeah, no, we definitely, it's funny, all these products, you look around the industry, we're interacting with data and technology at all levels. You mentioned automotive. Your car today, there's infotainment systems, there's driver assist systems. Those driver assist systems have cameras built in that look out in front of the car or behind the car. Your backup cam, right? Those are using those micro connectors that Mark was talking about. But at the end of the day, there's a heart inside of a computer that's running all that data that's pumping multi-gigabits on the inside. So that's your car today. It's a rolling computer system. Medical world, ultrasound systems. I mean, you show up the hospital now, your ultrasound used to be on a big cart. Now it's a tablet and a simple handheld probe. You got infusion pumps, you got all kinds of MRIs, CT scan systems. Those are bigger. They might have bigger connectors or bigger interfaces. And then you look at the tablet type devices, there's a small handheld, even wearables market, medical wearables today, glucose monitors, other type of devices. They're everywhere, and they're tracking data, monitoring information. Sometimes the patient can get their data tracked while they're at home, and they don't have to sit in a lab for 3 hours while some doctor evaluates data. They put a monitor on their body, they go home, and they come back the next day, and the doctor can read all that data off that monitoring device and understand what's going on with that patient in a real world environment.
Yeah, the medical industry is fascinating. You go from wearables, hearing aids, all the way to large machines. It covers everything in between. So far in your case, we were talking about PCIe 3.0, which is 5 to 8 gigabits. In Mark's case, we're talking about MIPI around the same similar range. In Zilli, higher speeds. The common denominator is all the customers, when they go through a new product development, they more than double their speed typically. So it's not just the connector that has to handle speed, it's how you go in the journey to do the design. So Zilli, besides offering these high-speed connectors, how else can we help the customer?
Yeah, so alongside the high-speed team in Hirose, we also have the signal integrity team, and there's experts in there that help with verifying the customer design. So if a customer is saying they'll use this connector for this channel, we can actually verify it for them. In addition, they also provide things like the simulation models and full reports that shows how well the connector performs in those speeds. So one of the things we see with our competitors is that they say connector can support that speed, and they can, but then the margin for those is not as good. And so you have to consider the entire channel, because your signal's not just going through connectors, going through like the PCB, the VS, and all of that stuff too. So our signal integrity team, they can provide some recommendations and verify that, in your entire channel along the connector, it can support those speeds as well. And another thing too is we actually provide something called loaner boards with these connectors mounted on them. And we loan these out to our customers so that they can take measurements themselves and verify, the simulation and also the measurements are very similar. So you can, see that the performance is exactly what we say it is. And, you won't have issues with later on where customers may design our competitors in, and then they actually finally run the channel in and then see that it's failing. They won't have that issue with our SI team helping them.
And we offer these services not only for people in the 56 gigabit per second. We also offer these services for our industrial customers that work in the single digits gigabits, right?
Yeah, so Mark mentioned the BK35. We provide simulation models and full test reports of that as well. And actually, one of the most commonly requested is the FX23 of PCIe Gen 3 because just a very popular series. We have a lot of customers asking for us for simulation and models of the performance, and we can provide that as well, and also provide support for that as well.
So, Dave, what's the role of Hirose in addressing innovation, and how do we help our customers in their journey to make their products smarter?
So we see the trends. We've been talking about it today, the data, the connections in the systems, and it's really interesting to see, we talk about innovation, such a big word, right? What does that mean? And when we're working with our customers, we're listening to what they're doing today. We're trying to understand how they're using the product, where they're putting the product, what technologies they're going to have coming down the road. Maybe we have to see, they went from, over the last year, they went from a millimeter to half a millimeter. Are they going to need 0.3 millimeter? Are they going to need 0.4 millimeter? Or they're at 56 gig today. They're going to be asking us about 112 soon. We know to ask those questions. We work with the customers. We try to understand the engineering groups where they're trending. We watch for that. We try to design the product to meet not just today's demand, but the demand that's coming down the road, understanding the applications of where they're going to in the future.
Wow, we covered a lot of ground, a lot of markets, a lot of products today. Hopefully our audience finds it very interesting. Thank you, Dave. Thank you, Mark. Thank you, Zili. I'm sure the audience has a lot of questions, so we're going to open for question and answer. Thank you.
Many thanks to the team for the presentation, and I'd also like to welcome Jorge as well to our Q&A to make sure that we provide most effective answers that we can for the audience questions. And I just wanted to take a moment to remind you all again that you can use that chat box that's over on the right-hand side of your screen. We have plenty of time left for Q&A. So presentation team, are we ready to get started with a few questions?
Yep.
Right. So our first question asks, how do Hirose's connectors help engineers with the special challenges that compact product designs present?
Well, that would be a great question for Mark. And the question is what compact is, right? Compact means different things to different people, but Mark can help answer that question.
Yeah, no, that's a good point, Jorge. I think a lot of people would consider everything we do as small, but I'll just talk about the smaller consumer electronics types of products that I mainly focus on. For compact design requirements, it's certainly a very, very common issue. I think I just recap, some of the points we discussed during the webinar, things like adding multiple signals and power routing capabilities within the same single small connector. I think one thing maybe we didn't mention or maybe we did, but we've got some connectors that are all about power, right? In a very small package that can reduce form factors for customers by getting rid of snap-on battery types of leads, but having that all integrated into a single connector. Things like adding higher retention force for connectors, but maintaining that small package. And also one thing too, I'm not sure, just to add something maybe we didn't mention so specifically on, most of these products that we've talked about today come in a really broad variety of pin counts. So, and that can become a critical design decision, right? You need a connector that doesn't have too many or too few pins to get done what you want, because that also adds to the size. So you'll see, especially on a lot of the, robust, mature connector families that we discussed today, you're going to find dozens of different pin counts, everything from, as small as 4 or 6 pins in some cases, all the way up to over 100 pins. So that's really another key factor to try to help somebody, a design engineer, make sure they're getting just what they need and nothing more, for keeping that size to a minimum.
Yeah, I would like to add one more thing. Being small is one of the key advantages of HeroCell, and it goes across all our product lines, from USB connectors to wire to board and board to board. And when you reduce the size of the connector, you reduce the size of the PCB, reduce the size of the enclosure, reduce the size of shipping. So it has a trickle effect in cost savings for the customer.
All right, our next question, this was particularly interesting to me from an industrial background where there's a lot of troubleshooting, maintenance, and the assembly is not always precise. And the question asks about the advantages of the floating mechanisms in the HeroSay connectors. How do those improve alignment in real world applications?
Yeah, that's a great question for Dave. Go ahead, Dave.
Yeah, that's industrial environment. You mentioned, David, that the challenge in there, the industrial housing designs, we don't always know exactly what that placement is going to be. Sometimes there's a little bit of an offset. Floating connectors will absorb that stack up tolerance if you have multiple connectors. If you have placement tolerance, you have multiple connectors on a single PC board. Each one has to be placed in just the right position. If you don't, you could cause some damage to the contacts on the PC board. And a floating connector can absorb that in the X and Y direction, and that will prevent damage long term. So this also has a benefit for durability overall. When you think of that industrial rugged environment, you're talking about a connector that mating between the boards. Now, we still expect all that structure to be around the connector for mounting it. You're still going to have standoffs holding it in place. But at the same time, you don't want any shock and vibe going through that connector and being applied against those solder contacts on the PC board. That floating feature will absorb that and prevent that from being a damage point or a failure point, especially long term. And you think about industrial equipment, 10, 20, 30-year lifespans on that type of stuff. You want that to last. You don't want to have to think about where that connector is going to be in 5-10 years.
Yeah, and floating allows you to have more than one connector. So that if you want to separate signals from power, you want to have separate two different signals, you can have two floating connectors, or one fixed and one floating, to accommodate that.
All right, moving on to our next question. This one's talking about EMI. It says, how does HeroSay address the need for EMI reduction in high-speed performance environments? And it particularly asks about the tight spaces that require 360-degree shielding.
Mark?
Yeah, I'll jump back to the shield box analogy I was using for some of our, shielded connectors. One, and maybe the questioner was thinking the same thing. Certainly a fair question is, well, that's great. You've got shielding around the 360-degree sides, but a shield box also has a top. So what's the lid of our little shield structure? And for that, the answer is it's a very well shielded FPC or PCB, design, because that is what creates the top and the bottom of the, effective shield box structure. We deliver a 360-degree around the edges, but the top still. And so we work with customers, and we have an SI, as I think we probably mentioned somewhere. We have a signal integrity engineering team here in San Jose, where I and Zilly are located, that roll up their sleeves and get involved, deeply involved sometimes with our customers here to help optimize FPC and PCB structures to work in conjunction with our higher frequency connector solutions, and in particular as well with those shielded structures. So it is, again, I think the question was about the small form factor applications of shielding and in high frequency. I guess one other point that I could just throw in that maybe we didn't touch on at all is the coaxial cables are still a very preferred path for getting high frequency signals from point A to point B with a minimized interference, or EMI. And we do have a family of very small, again, ganged micro coax solutions. So that's another one. And for those same MIPI type of solutions that I talked about, where a board-to-board or board-to-FPC is becoming more popular, there's still a large portion of engineers who would rather stick with a individual micro coax, which are just like the big coax cables you get at Home Depot, but these are 0.3 millimeters in total diameter, so they're tiny, and we put a bunch of those together in a little bonded cable. So that'd be another avenue to attack high frequency connections with a superior level of shielding.
And perhaps Zili can add to the higher speed connector, right, Zili?
Yeah, so as Mark mentioned, one of the things is the shielded structures, but also where you place your ground vias and which layer you're placing the FPC ground layer on. All these things do matter in kind of dealing with the less about EMI, but more about the crosstalk between your